Hi, this is Alex from Alex's World of Math, and today we're gonna go through this example, and then after this we're gonna explore uh what category this example falls into. Keep in mind that when I say category, I mean like if we're having ordered selection or unordered selection, or if we have repetition allowed or distinct choices that we have to make for the k amount of selections. And so this is gonna be a very quick example. So let's get started. All right, so from the last example, we found that n choose k um gives the number of subsets that can be formed from from a set uh, with n elements. So number of subsets of size k. That can be formed from the set of n elements. And so now we need to find how many total subsets of any size can be formed with the set of n elements. So one intuitive way that we can do this is just to add every single possible size subset from 0 all the way up to n as k. So we're basically finding the sum from I is equal to 1. Sorry. Let's go to 0 all the way up to k of n choose k. K to n. So k is equal to 0, and then you're going up all the way to n, because if you have a subset of if you have a set of size n, the largest subset is of size n, the same subset. So I mean the same set as the subset. And so you also need to make sure that you understand that subsets are unordered, but that doesn't mean that finding the total subset is unordered. All right, so let's get started. So although it's not like we can't really find this explicit formula by just testing, we could try to find some pattern, right? Because if we try to test it, we can't ever reach n hypothetically because it's arbitrary. So let's just test it for some n. So if n is equal to like, let's start with n is equal to 0. If it's 0, then you only have 0 to 0, which is equal to 1. And how do I know that? Because from the choose formula, you have this 0, 0, and that's all equal to 1. And so, yeah, so that's equal to 1, and it's equal to 1, then what will happen? Well, you're gonna have 1 choose 0, that's 0 factorial over 0, 1 minus 0 factorial. 0 factorial is equal to 1. But you also have another option now. You have the option for 1 choose 1, which you're finding number of subsets of size 1. And so you'll have 1, 1, 1 minus 1 factorial. And then you have 1 factorial, which is also equal to 1. So now, if you add them together, how many total subsets? You have 2 total subsets for n equals to 1. But if n is equal to 2, you will have 3 possibilities, right? You have 2 choose 0, 2 choose 1, and 2 choose 2 for a subset of size 0, 1, and 2. For 0, it's going to be again evaluated to 1. Anything choose 0 is equal to 1. And then 2 choose 1 becomes 2. 2 choose 2 is 1. I did this through formula, but these are common binomial coefficients. Like anything choose 0 is equal to 1, anything choose itself is equal to 1, and anything choose 1 is equal to itself. I mean, sorry, anything choose 0 is equal to 1, and then anything choose 1 is equal to itself. And so this is all gonna equal to 4. You can confirm this using the formula, but just for time's sake. So yeah, we have n equals 0, sorry, with 1, 2, and we're going to 4. Do we see a pattern? So yeah, let's just confirm this. N is equal to 3. 3, 0, 8, 1, 3, 2, and 3, 3. That's 1, 3, 3, 1. Also 8. And so indeed we have 1, 2, 4, 8. And so we can hypothesize that the answer is 2 to the power of k. The answer to the question. But how do we confirm this? Well, let's think of this in a different way. Um, so we could use like proof by induction to prove this true, but we can also just think about it another way, right? So we can picture the subset of size n. It has distinct items, and so take the set 1, comma 2, comma dot dot dot, comma n. This is a set of size n, and they're all distinct items, so we're good. And so we can picture this as a binary set. Not maybe not what you might think, but it's like you have n spots, and each of them n spots, and each of them can be either 0 or 1. And if it's 0, then that element will not appear in the subset. So like if this was 0, then that corresponds to the first element in this set, which means that the first element will not show up. If there's another 0, then the second element will not show up. So if you had the set like 1, 2, 3, then you can think of this like how many subsets you can form. Well, you like one subset that you can form is if this is 0, this is 1, 0, then that means 1 will not show up, 2 will show up, and 3 will not show up. And 2 is indeed one subset of the set. And so if we think about it, creating subsets using this method, then we have 2 choices per slot, per slot corresponding to each element. And if each slot is corresponding to each element, then we have 2 choices for the first slot. And then we have 2 choices for the second slot, 2 choices for the third, and all the way up to the nth slot for the corresponding to the nth element, if whether or not it's going to appear in the subset to be 2. So you have 2 to the power of n. And in this case, I meant k because we're choosing k elements, right? So we want k elements from the subset. Wait, yeah, I think I meant, yeah, I meant just n, right? Yeah, I meant just n because we don't have any k that we're asked for. So we're keeping it to power of n because the size can be any. We're going up to a set. We're using a set of size n. So the answer is going to be 2 to the power of n. In this case, when I said 2 to the power of k, I meant to the power of n because at n equals 0, you have 2 to the power of 0. At n equals 1, you have 2 to the power of 1, which is 2. When you have n is equal to 2, you have 2 to the power uh, of 2, which is 4. So that works. So the answer is 2 to the power of n. All right, and let's go through another quick example. So say you have a combination block that uses n digits from 1 to n. N different digits just from 1 to n, and the log requires a sequence of k digits to open. So you have k digits, 1, 2, 3, dot, 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 k, right? Um, and so, um, and each of these sequence of k digits, each of these elements in the sequence of k digits uses n different digits. So this one has n choices. You have n choices. You have n choices. Each element in this k digits has n different choices, right? Um, and so you have n again. So your answer is n to the power of k, right? Because you're multiplying n k times. So it's gonna be n times n times n, blah blah blah, n times n. And that's k times. Yeah, and then you ask how many different combinations you use a set log. Um, and they also said that the digits can be repeated. That's why I used n for every single one. They said that they have to be distinct. Then you have n minus one and minus two. And we're gonna have the last one as like n minus k plus one, which would be our permutations formula. Um, but in this case, we're asked for it repeated. So we have n choices for every single log. And the order of the digits matter. Well, yeah. Uh, we're choosing this ordered choices because they're not asking for any groupings, right? This is arrangements. Um, so yeah, the answer will be this for when order matters and repetition is allowed.